Hello, Math 130 students. We are going to pick up on page 15, section 6.7, solving radical equations. A radical equation is an equation that contains a variable in a radicand. So to solve our radical equations, we have our steps 1 through 6. So we're going to follow these steps and try to see if we can solve for each of these. So let's look at number 1. I have the square root of a is equal to 8. So step number 1, we want to rewrite the equation so that the radical is isolated. Well, it's already isolated in number 1, so that's done. For step number 2, raise each side of the equation to a power equal to the index. Well, the index here is a 2, so I'm going to raise it to a 2 power. So when I do that, I'm going to get that the square root and the square cancels out. So I'm left with a is equal to 8 squared. So then a, when I combine like terms, well, 8 squared, 8 times 8 is equal to 64. I need to repeat the steps if necessary. I don't need to. Then I solve the equation. I did that. Now I want to make sure that I check the solution. So does the square root of, and I have 64, is the square root of 64 equal to 8? It is. So I know that a is equal to 64 is going to be my answer. So now I want to do the exact same thing with question number 2. So we want to make sure for step number 1 that the radical is isolated. So here it is not isolated. So not isolated. In order for this to be isolated, I need to add 3 to both sides. Then the radical would be isolated. I would have the square root of x minus 6 is equal to a positive 3. Now I have isolated it. Now I'm going to raise each side of the equation to the power equal to the index. So that's a square root. I'm going to raise it to the second power. So now the square root and the square cancel. So I'm left with then x minus 6 is equal to a 3 squared. Well, I know that 3 squared is really equal to 9. From here, I add 6 to both sides. So I'm going to get that x is equal to a positive 15. Okay? So step number 2, step number 3, I didn't need to do step number 4, I did step number 5, but now I want to make sure that when I plug this back in, I'm actually going to get my 0. So the check, this is your last step. So I have the square root of x minus 6 minus 3 is equal to 0. So that number that you're plugging in here is 15, since you got that x is equal to a 15. So let's see if this is going to be true or not. So the square root of 15 minus 6 gives me the square root of 9, which is 3, minus 3. So 0 is equal to 0. So I've checked it and I verified that the answer does work out. So my answer here really is a 15. So let's think about this when we go to number 3. When I go to number 3, the radical is isolated. Perfect. So now I raise it to the power of that index, which is a 2 since it was a square root. So the square root and the square cancel. So you're left with 2x plus 3 is equal to a negative x squared. So negative x times negative x is really just an x squared. So then from here, I'm going to subtract 2x and subtract 3 from both sides. So that way I can have a 0. And now I have x squared minus 2x minus 3. From here, I can factor. And if you remember, you're going to have your a times your c and your b value, and then your new b value. So here we want two numbers that multiply to a negative 3. and adds up to a -2. Well, the only numbers that multiply to 3 would be a 3 and a 1. If you want it to add up to a -2, it would be a -3 and a +1. So I have an x minus a 3 and an x plus a 1. And remember, the only way I'm able to do that is because I have that leading coefficient, which is 1. So now when I split it up, I have x minus 3 is equal to 0. So x is equal to a +3. X plus 1 is equal to 0. So x is equal to a -1. So now I'm going to do my check. The first one I'm going to check is that x is equal to 3. So does the square root of 2 times 3 plus 3 equal to a negative x value? And remember, that value that we're plugging in here is 3. Does this work out? Well, let's see. The square root of 2 times 3 plus 3 is equal to 3. Does that equal to a -3? It does not. So we have to cross that answer out. Now we are going to try the exact same thing for our second value. So our second value, we are checking that x is equal to a -1. So I have the square root of 2 plus 3 is equal to a negative that. So the value I'm plugging in is a -1. So let's see, the square root of 2 times a -1 plus 3, that gives me a +1. And a negative times a -1 gives me a +1. So that one does work out. So because that is true, the only answer that works out is x is equal to -1. So for number 3, I found two possible solutions. X is equal to 3, x is equal to -1. When I checked both of these solutions, the 3 did not work out, so I canceled it out. It's a worthless possibility. And then I checked x is equal to -1, and it does work. So that is the only possible answer that we have for 3. Okay. Now let's look at number 4. So for number 4, the radical is not isolated. So I would need to subtract a from both sides. Then I would have -26a plus 12 inside the radical is equal to a -a plus 6. So then from here, because it's a square root, I would square both sides. So I know that the square root and the square will cancel, so I'm left with a -26a plus 12. And here I have a -a plus 6 and a -a plus 6. What I want to do is, I like the box method for this because I have a lot of negatives and I don't want to lose myself in the negatives. So -a, and I have a 6, and it's a -a times a 6. So I'm going to get this as a positive a squared, and then a -6a, a -6a, and 6 times 6 is a positive 36. So I would have an a squared minus 12a plus 36. And I got -12 by adding -6 times -6. That's how I got this -12a. So now I have my -26a plus 12. And remember, I had FOILed that out, and I had gotten an a squared minus 12a plus 36. From here, I want to isolate, so plus 26a and minus 12. So that will give me 0 on one side. And I have negative 12 plus 26, which is a positive 14a, and a 36 minus 12, which is a positive 24. So when I factor this, and of course you can do the AC method if that's what you're comfortable with. So I have a times c, which is my 24, my b value, which is 14. So let's think about our numbers that can multiply to 24 and adds up to 14. So I wrote all of my multiples of 24 out, and the only ones that's going to add up to a 14 if it's 2 and 12. A positive 2 and a positive 12. So of a plus 2 and a plus 12. So a plus 2 is equal to 0. So a is equal to a negative 2. A plus 12 is equal to 0. So a is equal to a negative 12. Now I have to check my solutions. So I want to make sure that the solutions that I found are actually legit solutions. So let's go ahead and do our check. So if I'm going to do my check, let's do the first one of a is equal to a negative 2. Well, I have the square root of negative 26 times my a plus 12 plus a is equal to a 6. So here, that number that I'm going to be plugging in is a negative 2. So let's see what I get on my calculator. So the square root of a negative 26 times negative 2 plus 12 plus a negative 2 gives me 6. It works out. So a equal to negative 2 is perfect. Now let's try this for a is equal to a negative 12. Let's see if that works out. So now I'm going to plug this into my a value. So I have a negative 12 that I'm plugging in. So let's do that. And I get 6 is equal to 6. So both a is equal to negative 2 and a is equal to negative 12 are good answers. Now let's look at number 5. If I'm looking at number 5, the first thing I want to do is add x to both sides. So that negative 6x minus 5 inside the square root is equal to a positive x. Now I want to square both sides. So that negative 6x minus 5 is equal to my x squared. Now I'm going to add 6x to both sides and add 5 to both sides since I want this side to equal to 0. So I have x squared plus 6x plus my 5. And to factor this, you can do the AC method or the guess and check. So 5 times 1, when I multiply them together, it adds up to a 6. So x plus 5 is equal to 0. So x is equal to a negative 5. X plus 1 is equal to 0. So x is equal to a negative 1. So now we want to do our check. Remember, we have the square root of negative 6 parentheses minus 5. Maybe my square root should be a little bit nicer here. There we go. And it was a negative 6. So negative 6 parentheses minus 5 minus my x value equal to 0. So the first number we're going to try is x is equal to a negative 5. Let's see how that works out for us. So I have the square root of negative 6 times negative 5 minus 5 minus a negative 5. And that gives me 10 is equal to 0. So that is not a good answer. So I throw that answer out. Now let's try this for x is equal to a -1. So I'm going to plug in a -1. Let's see what we end up getting. So I have the square root of -6 times my -1 minus 5 minus my -1, and I get 2 is equal to 0. So that's not a good answer either. So I found two possible solutions, -5 and -1, and both of them did not work out. Both of them gave me false statements. So what you can say is, okay, in the entire world there is two possible solutions and neither of them worked, so it's going to be a no solution. Now, what's different with number 6 is that our index is different. Our index is 3, but that just means we raise everything to the third power. So now I have that the third root and the third power cancel, so I'm left with an x minus 8 is equal to 2 to the third power. But I know that 2 to the third power is just 8. So I'm going to add 8 to both sides so that x is equal to a positive 16. And of course we have to check the solution. So I'm looking about the third root of x minus 8. Does it equal to a positive 2? So the only answer I have there is a 16. So 16 minus 8 is going to give me an 8, and the third root of 8 is 2. So that works out very nicely. So x is equal to 16 is going to be my answer. Now for number 7, same process. So I'm going to subtract 13 so I can isolate the fourth root. So then 15 minus 13 gives me a positive 2. So since it's to the fourth power, everything gets risen to the fourth power so that the index and the power cancels. So 2d minus 8 is equal to 2 to the fourth power. But 2 to the fourth power is really a 16. So I'm going to add 8 to both sides. So that 16 plus 8 is equal to a 24. And divide by 2 on both sides. So that d is equal to 24 divided by 2, which is a 12. And of course I want to check my solution. So I have 2 parentheses d minus 8 all inside my fourth root plus 13. Does that equal to a positive 15? And remember, I am plugging in a 12. So that is the answer that I got. Well, 2 times 12 minus 8 is going to give me a 16. And 2 to the fourth power is 16. So the fourth root of 16 is going to be 2. And 2 plus 13 is equal to a 15. So that d to the 12 checks out. That is a solid possibility that gave us an answer that we checked and verified. Now for number 8, what's slightly different is that instead of writing it as a root, they gave it to you as a fraction power, which is fine. It just means that whatever this denominator is, that's what I'm going to multiply it by. So since the denominator here is 3, then I'm going to multiply by 3. So always multiply by whatever that denominator is. So now I'm going to have 2n minus 9. And if you think about it, 1/3 times 3 is just 1, so it cancels each other out, and I have 1 to the third power. But 1 to any power, so 1 to the third power in particular, is just 1. So now I'm going to add 9 to both sides, so that 2n is equal to 10. From here, divide by 2 on both sides, so that n is equal to 5. Now, of course, we always want to check and verify our solution. So we have 2 parentheses n minus 9, all to the 1/3 power, and we want to know whether or not that is equal to 1. So what we are plugging in here is a 5. So let's see what happens. 2 times 5 minus 9 is equal to a 1. And a 1 to the 1/3 power gives you 1. So that definitely checks out. So n is equal to 5 is going to be your answer. Now, for number 9, I have 2 radicals. And so there really isn't a way to isolate the radicals since there's 2 of them. So what I need to do is I need to repeat some stuff. So let's start off by squaring both sides. So this is really x minus 3 inside my square root plus 2 times my x minus 3 inside my square root plus 2, right? It is written twice, right? So that means I need to have to FOIL that out. And it's equal to, and the square root and the square cancel, so we're left with a 2x plus 2. Now, what I like to do when I have a foiling with radicals, I just like to do the box method. It makes it a little bit cleaner for me. So I'm going to have the square root of x minus 3, and it looks like I also have a positive 2. And I have the x minus 3 inside the square root, and a positive 2. So now that's going to be a little bit easier to multiply, or at least easier on the eyes, at least for me. If you like to FOIL and you're fine with that, go ahead. That's not a problem. So here I have square root x minus 3 times the square root of x minus 3, which just cancels out the square roots, so you're just left with an x minus 3. Here I have 2 square root x minus 3. Same thing in this square, and 2 times 2 is 4. So at the very least, I can combine these two, so I can have x minus 3 plus 4 square root x minus 3 plus 4. And then from here, I can see that this negative 3 and this positive 4 can add together. So negative 3 plus 4 will give you a positive 1. So again, I like to do my scratch work over to the side so it doesn't mess up what I'm doing, but at least I can go back and check it in case I made a mistake somewhere. So when I FOIL this out, I ended up getting an x plus 1 plus 4 square root x minus 3, and I still have that 2x plus 2 on the other side. So what I'm going to do from here is now I'm going to repeat the process. So now I'm going to subtract x from both sides and subtract 1 from both sides to isolate that variable, that, square root. So I have 4 square root x minus 3 is equal to an x plus 1. So now from here, I'm going to square both sides. So this is saying 4 times the square root of x minus 3 times 4 square root of x minus 3 is equal to my x plus 1 times my x plus 1. So here, I'm going to have 4 times 4, which is 16. And then x minus 3 square root times x minus 3 square root cancels out the square root since it's squared, so you have that x minus 3. And when I FOIL the next side, so FOIL, your first, outer, inner, last, you would get x squared plus x plus x plus 1. And then from here, I'm going to distribute that 16 in. So 16x minus, and 16 times 3 is 48. And I can combine those two x's together to give me a 2x. And now I'm going to set this equal to 0. So minus a 16x to both sides and add 48 to both sides. So this entire side cancels. I'm left with an x squared, and negative 16 plus 2 gives me a negative 14x, and 48 plus 1 gives me a positive 49. And if I were to factor this out, well, I know that if I were to have a negative 7 times a negative 7, it gives me a positive 49, and negative 7 plus a negative 7 is a negative 14. So I'm going to have, since they are exactly the same, I just have to do one of them, since it would just be repeated. So x is equal to 7. And don't forget, at the very end, you definitely want to check your final answer. So my original equation, I have my x minus 3 inside my square root plus 2 is equal to 2 times my value plus 2, and all of that is in my square root. So what I'm plugging in here is 7. So I'm going to do each side separately. So the square root of 7 minus 3 is 2, plus 2 gives me a 4 on this side. And now, let's see what happens when I do it to the other side. So on my calculator, the square root of 2 times 7 plus 2 gives me a 4. So they are exactly the same on both sides. So x is equal to 7 is a good, legit answer. So that is the answer that we keep. Okay, if you guys have any questions, please let me know. Email me, email the Math Success Center, go to tutoring, and we also have our embedded tutor. Thank you.